Hi guys, welcome back to the channel. I hope all of you are keeping great. So today we are here with a very interesting question. You have been given a linked list of n nodes in total, and you have been asked to reverse every k nodes in that linked list. That is, you have been given a number k and you have to reverse every k nodes in the linked list. That is, pick up the first k nodes, reverse them. Pick the next k nodes, reverse them. Then pick the next k nodes, reverse them, like that. And you have to reverse the linked list in this manner, that every k nodes of the linked list have to be reversed, right? So we'll discuss the algorithm, approach and code of this question. So let's get started. So let's discuss the algorithm of the problem. Now let's imagine that you have been given a linked list of 6 nodes like this: 1, 2, 3, 4, 5 and 6. And let's imagine you have been given a number k whose value is equal to 2. So the question says that you have to reverse every k nodes, that is, you have to reverse every 2 nodes of the linked list. That is, reverse these 2 nodes, then reverse these 2 nodes, then reverse these 2 nodes and return the final list. So the final list should look like, when these 2 nodes are reversed, they will be something like this: 2 and 1, right? Then these 2 nodes will be reversed. It will be like 4 points to 3, and these 2 nodes will be like 6 points to 5, and these links have to be connected. So you wish to obtain this output 214365, and your task is to find how should we do that. So now first I will request all of you, if you have not seen the previous video of reversing a k list or reversing a linked list in an iterative manner, so please go and watch that video first, because then you will be able to understand this video with a better clarity and concept, right? So starting 1, 2, 3, 4, 5 and 6. So what approach we'll follow is, whatever the value of k is, now in this case k is equal to 2, so what we'll do is, for the first k nodes, these are the first k nodes, for the first k nodes we will follow the iterative approach of reversing a linked list. I have already made a video on reversing a linked list in an iterative manner, so please go watch that out. So first k nodes will be reversed in an iterative manner, and from the next node, that is from the k plus 1th node, so this is the k plus 1th node, right? So from the k plus 1th node till the last node of the linked list, this entire part we will send it in the function once again, that is, this will be reversed using recursion, that is recursive manner. Alright, so now let's imagine we have already applied recursion from the k plus 1th part to the last part. So recursion will return us something like this: 4, 3, because these two will be reversed, 4, 3, then 6 and 5. So 4, 3, 6, 5. So let's imagine recursion has already returned us this entire value 4, 3, 6, 5, right? And 1 and 2, we have to reverse these k nodes in an iterative manner, right? 1 is the head of the linked list, we all know that. So when we reverse 1 and 2 in an iterative manner, 1 and 2, so basically this link will get reversed, right? So this link will point something like this now, from 2 to 1, and we already have the part which our recursion part has returned us, that is 4365. Now note one thing in this algorithm: though we have reversed this link of 1 to 2, but the head still remains at 1, because we have not changed the position of head of linked list, right? So now what we desire to do is, we wish to join these parts, that is these k nodes, with the rest of the nodes. How can we do that? So what we'll do is, whatever the head is, 1 is the head, in the next part of head we will connect whatever we get from the recursive function. That is, the recursive function will return us a particular value. We will store that particular value in the next of head, right? So after doing that, our list will look something like this. This is 4, this is 3, this is 6, this is 5. Right? And now 2 becomes the new head, and the previous pointer also points to 2. Why so? Because we have seen that whenever we reverse a linked list, so the last part, that is this part from where the new linked list starts, the previous pointer points to that part. We have discussed it in the previous video of reversing a linked list in an iterative manner, right? And since the linked list starts from this node itself 2, so 2 becomes the head pointer also, right? So this was pretty much the approach that we followed here. Now we'll see the coding part. So let's come to the coding part now. Now, as we all know, first of all, we have to create a structure of node. That is mandatory for every question of linked list, right? So let's create a class node, and a data has to be included here, and a next pointer has to be included here, right? Now we create a constructor. Constructor is a function with the same name of a class, right? And let's initialize our data by the value, by the parameter which constructor is taking, and our next pointer by null, right? So we have created the structure of a node. Now moving forward, let's come to the actual part. So class calc, let's declare a function public static. Now we all know that in the end we have to obtain a reversed linked list of every k nodes, right? So we will accept, how can we traverse the entire linked list? By taking the node of that, by taking the head of that linked list. And what is head? Head is actually a node, right? So the return type of this function has to be node type. All right, and let's give this function a meaningful name, reverse, right? Now let's accept some values. Node. Now please don't confuse with these two nodes. This node is actually the type, the data type, right? And this node is just a name. It can be anything, just like we write node head. So this is an alternate or substitute for head, right? I am using node this time. And we also accept the value k. K is actually the number which we accept, because we have to reverse k nodes at a time, right? So we'll use 3 pointers, node, current pointer, and we'll initialize it to the head pointer or the node which we just accepted in our function. A previous pointer will initialize it to null, and a next pointer which will initialize it to null as well. We'll take a count variable and initialize it to 0. Now we'll run a loop till the current does not reach null. That is, the linked list should not be finished till the time we are traversing it, right? Otherwise the loop will exit. And count has to be less than k, because we have to reverse k nodes at a time, right? So we have to keep count in consideration also. So now what we'll do is, first we'll initialize next. In next we'll put the value of current dot next. That is, whatever the current node is, its next node will be pointing to, its value will be stored in next, right? Now, so this part is actually, marking next node, Now we have to reverse the link. So current dot next equals previous. This is actually reversing the link. Reversing the link means if 1 was pointing to 2, then after this step 2 will point towards 1. So this is reversing the link, right? And we have to update all the 3 pointers. We have to move them one step forward, as we saw in our previous video of reversing the linked list. So previous will take the value of current, will move one step forward, and current will take the value of next, that is current will also move one step forward. So if this was previous, this was current, this was next, in next step previous takes this value, current takes this value, next takes this value. In another step, next step, previous takes this value, current takes this value, next takes this value, right? And finally we have to increment the value of count. So this was our for loop, right? So if you all have watched the last video of reversing a linked list in iterative manner, so till this part, till this line, right, this entire function is the actual mirror image of the code that we wrote in reversing a linked list of n nodes, right? Now the only change which happens here is, since this part has has reversed exactly k nodes, but we need to reverse first k nodes, then the next k nodes, then the next k nodes, till the linked list is finished, right? But up till now we have reversed only the first k nodes in an iterative manner. So as we discussed in the algorithm, first k nodes will be reversed in an iterative manner, and the remaining linked list will be reversed in a recursive manner. So now recursion part comes into play. We check if next pointer is not equal to null, that is there are nodes ahead, right? Checking if there are nodes ahead, because definitely there should be some nodes left, only then we can reverse those nodes. If the linked list is finished, then we cannot reverse any further nodes, right? So what we'll do is we'll call this function again, reverse, which we created, recursive calling, right? We'll pass the value of next, the k plus 1th node, and k, the number which we were given in the beginning, right? So this part, it is automatically reversing the remaining linked list, right? And whatever this will return, we will store it in the next of node, Why is it so? You can just go back and watch the algorithm that we discussed, because when we were something like this, 4 3 6 5, and we had 1 and 2, so we need to join these k nodes with the remaining linked list. So this was our head, and in this case we have taken the head as node. So in the next of node, we give the value of whatever has been returned by the recursive function. So this is actually what we're doing here. This is our recursive call, and whatever it will return, we'll store it in the next of node. This is the node, in the next of node we'll store it. All right, so let me just erase all this. Yeah, and after all this, our task is pretty much finished. We'll just go and return previous, because in the end we all have seen that previous is the node which will be pointing towards the head of the reverse linked list. So our final linked list will look something like 2 1 4 3 6 5, and previous will be pointing here, and this is the new head. So we are actually returning previous. So this was our problem. We can discuss one more thing here, the time complexity of this problem. Now see, there are n nodes in a linked list, and we have to traverse all the n nodes, right? So one node at a time. Hence the time complexity is of the order of n, and the space complexity, it's just a constant, right? Order of 1, because we are not taking up any extra space, right, apart from what's needed. So yeah, that's it. So guys, I think that by now you might have understood the concept and logic of reversing every k nodes of a linked list, right, of n nodes. So what the one thing which I'll suggest you here is, to understand the current video completely, first you have to, I'll suggest you to watch the previous video, because there's a lot of link between videos, right? So if you have already watched the previous video, you'll be able to understand the current video, with much more clarity and understanding. So that's all for today, and thank you for watching. We'll meet very soon, and happy coding.